What's up, chemists? In this ALEX topic, we are given a chemical reaction and we're asked to make a galvanic cell out of it. So here is our reaction for the example that I have here. And we need to think about this reaction and think about what kind of a cell it would make. So the first question that it asks is, it wants us to write a balanced equation for the half reaction that takes place at the cathode. Okay. Now you should recall by now that the cathode is where the reduction takes place. So what we're looking for this problem is we want the reduction half reaction. So what is being reduced in the problem above? Let's go ahead and assign some oxidation numbers and see if we can figure this out. So for oxygen, the oxidation number is 0 on the left-hand side, and on the right-hand side it's -2. The oxidation number for hydrogen is +1 and +1. For bromine, it's -1 and 0. So it looks to me like the oxygen is being reduced. So we have to do a little bit of work here. We've got O2 on one side, and that O2 is going to H2O. So we'll need 2 H2Os, we'll need 4 H pluses, and that means we'll need 4 electrons. All right, so the half reaction is going to be O2 plus 4H plus 4 electrons going to 2 waters. And of course, you're going to have to put in the phases for Alex, or else Alex will yell at you. Okay, the anode, the next question is, what half reaction will take place at the anode? And that is the reaction that is our oxidation. So for that one's going to be quite a bit easier. We'll just do it right in the square here. So we're going to have Br minus. We'll have, sorry about that, Br minus. We'll have 2 of those, and 2 Br minus going to Br2 plus 2 electrons. That's the half reaction that will occur in the anode. That's the oxidation part. Third question says it wants us to calculate the cell voltage under standard conditions. So let's think about our two half reactions. And our two half reactions are the reaction of oxygen. If we look up the E0 for that one, E0 for that is positive 1.23 volts. I didn't actually look that up in the ALEX data tab. I don't know where that is or how to get to it, but I assume that you folks do by this point in the course. I looked it up in another textbook, but it should be the same in the ALEX data tab. You should get 1.23 volts for that. The other half reaction, I'm going to write it as a reduction now. So Br2 plus 2 electrons going to 2 Br minuses. Okay. And E0 for that is 1.07 volts. And again, I looked that up in another textbook, but the ALEX data tab should be the same. Okay, so we have the more positive value being our reduction, and the less positive value, the less positive reduction potential, is associated with the half reaction that will run, in this case, as an oxidation. So we can calculate E0 for our cell then, and that's going to be E0 for the oxygen minus E0 for the Br2, and we'll have 1.23 volts minus 1.07 volts, and that gives us 0.16 volts, if I did my math correctly. So it's just a very small voltage. This is not going to be a very good battery or a very good galvanic cell, but that's what we got. So 0.16 volts would be the answer to the end. Okay, so concepts here again. The cathode is the place where the reduction takes place. We need to be able to take an overall reaction and suss out what the oxidation reactions are and what the reduction reactions are. And you can use oxidation numbers as tools to be able to get that done. And then we need to be able to combine E0 values to get E0 for the overall cell. That's it. Good luck.